Hello!
We're back.
Absolutely. For question 2, we're doing the entire Core 1 paper of 2008. We've gone through that, so let's do it.
Yep, so I'm going to read out what it says in the question before going through the actual question. So, the curve of the equation y equals x to the 4 minus 32x plus 5 has one stationary point at M.
It does, and as it's x to the 4, it's a polynomial, and it's got a stationary point. So, what's that mean?
Good question, good question. Questions are good.
Questions are good, I like questions.
If we have an x squared, you know they look like that, they're parabolas, it could be upside down.
Or a sad face.
The stationary point is this bottom point, or the top point if it's a negative one.
Yeah.
It's just the point where it's not increasing or decreasing.
So its gradient is 0 here. With that out of the way, let's get part A done.
Yep.
So part A.
Find dy by dx.
Now dy by dx is just differentiating, as this is the way you have to do that.
Yep, we have videos of that on in the Core 1 playlist so you can learn your stuff. But we'll go through it here anyway.
Yep.
So what you do is you take the power of each section of a polynomial, you times the coefficient by the raised power, then reduce the power by 1. This makes more sense when I go through it here. So this was x to the 4, you times the beginning bit by 4, the coefficient, it's 4x, then reduce the power to 3. Here I had an invisible to the power of 1, so you times the coefficient by 1, which is just minus 32. When you reduce the x power to 0, it becomes just 1, so you just don't write any x.
And when you times that by the power of x, it disappears because the power of x is 0.
Yes. And there you go. That's part A done, that's
That is
differentiation. Check out our chapter if you don't know how to do that.
Ta-da! So, part B.
Find the x coordinate of M, and it says in the question, M is the one stationary point of this polynomial.
Absolutely, a station point where the gradient equals 0, differentiation tells you the gradient, so you need to find out what it equals when it equals 0.
Yep. So you make this differential equal to 0. So 4x cubed minus 32 equals 0. You're going to find out what the x value is at that point. So first what Triv's done, he's taken the 32 over that side to make 4x cubed equals 32. Then he's divided it by 4, because if you cube root it there, that would make it rubbish math, it would be horrible. X equals 2, that is the x coordinate of M.
Absolutely.
If it asks for just coordinates, you could then put that x value back into here to get a y coordinate that corresponds with it.
That's what you do, but as it just wants that, so yes.
It's all done, yeah.
Part
C
C.
part 1, find d squared y over dx squared.
To get that, you just need to differentiate our first differential here.
Yep, it's a second one.
Yeah. So
Same rules apply. You take the raised power times it by the coefficient. 3 times 4 is 12, x reduce that to 1. Constant disappears again.
it becomes 12x squared. Part 1 out of the way.
Part 2 is hence. Hence means using something you've done before in the question.
So we'll use this.
Hence determine whether it's a maximum or a minimum.
There's a couple of rules to this, isn't there?
There is indeed. You've got to make it equal to 0. And you put in an x value, and if it's greater than 0, it means it must be a minimum, opposite to what you'd think.
Yeah.
And if it's less than 0, if it comes out to be a negative number, which sometimes it does, it means that that particular point must be a maximum. Again,
It means it's the top of a curve as opposed to the bottom. But you put the point that you know in, which is 2. So 12 times 2 squared, 2 squared is 4, 12 times 4,
48. Now 48 is greater than 0,
it is.
and you say 48 is greater than 0, this implies...
Or, yeah, you could do that, and that's, today you do a little, like that.
Equals with a little arrow at the end.
Yep.
Or a sideways smiley face.
It's
This implies it's a minimum, because it's above 0. If it was below 0, it would be a maximum.
It would. That's C part 2, and then final part.
D. Determine if it's increasing or decreasing when x equals 0.
I'm going to do D within the rest of this bit, but I'm not going to rub out our gradient.
No, because we're going to need that.
We are going to need that. So Wayne, how do you do that?
Well, what you do is you get this gradient. This is finding out at any point what the gradient is at that point.
Yes.
So you put in the different x values and it'll tell you the gradient at that point, because on a curve, on a polynomial, it's changing all the time.
It is. So you put your point in, and then you'll find out what it is. And the point they've given you
It's
is
x
0.
equals 0. So you put 0 in where it says x.
You do. So 4 times 0
0
cubed minus 32.
Is just going to be minus 32.
It is. So that means it must be decreasing a lot.
Yes, quite rapidly. So a very negative gradient there.
It is. And that's question 2.
Yep, this was differentiation mostly.
Yeah, mostly. And that out of the way, on to question 3.
Yeah.
Whizzing through this.